and welcome everyone to Embedded World 2025. We are right now at Microchip stand, and today we are going to see some of the demonstrations of Microchip's latest solutions like the 10BASE-T1S or the Curiosity Kit and their microprocessor, the SAMA 7G54. Let's go.
I would like to take just a minute to introduce myself first. So my name is Hakim Sharif. I am a technical marketing engineer working for the microprocessor business unit at Microchip. Okay, let's talk about the demo. So yes, here we have an object detection demo. We have reproduced a small truck loading bay. And the idea here is that is to show that using the SAMA A7G54, so this is an ARM Cortex A7 microprocessor, we can do basically machine learning. This microprocessor has no hardware acceleration for machine learning, except from the Neon instruction set, but we can do object detection. It all depends on the requirements.
What is this board?
This board, this is the SAMA A7G54 evaluation kit. So it has the SAMA A7G54, our single-core ARM Cortex A7 microprocessor that is here. And that board runs a Linux operating system. So it runs our Linux for Microchip distribution. It has many interfaces to test and use the microprocessor.
Oh, you see that you're running Raspberry on here, right?
Yes, exactly. Here we have a display. So one thing that I would like to emphasize is that this application is not, these use cases are not meant for having video streaming. We want to do processing at the edge. This is important to understand. The model is here. We do processing at the edge, so we show a video stream only for the demo. That's why we use a third-party tool, but in real life there would not be any video streaming.
All right. So can we show just the demonstration?
Yeah, you can move a truck, for example.
So
go ahead.
Moving here. Let's make this type of parking. And it accurately detects the objects, the cars. Is it already being used somewhere?
So not the specific demo, but we have customers that are interested by object detection in general. So that's just an example between many others.
Okay, so it can also configure like if it will learn, but can it learn? No.
Yeah, so let me talk about the learning phase. So we are partners with Edge Impulse. Edge Impulse, that's a company that provides an easy-to-use toolset to train models and deploy them, and you can train your own model. So our customers can train the model, for example, to do people detection, to do car detection, or many things else.
All right, so we can see that there are different, let's say, type of cars, lorries, and
yes.
We will park over there. Okay, so it detects, and if I will put my hand over there, okay, it detects that there is an object over.
Yes, here as well, it has detected that. So it all comes to the use case. The images that have been used, we did not specifically imagine that someone would put their hand here, for example. That's not part of the use case in the real life. But so here we have trained only with a neutron background. Okay,
and do you think that we can improve it in the future, or?
Yes, of course, there is always room for improvement. It all depends on the use case. So let's say, for example, you want to do a similar application, but in a parking lot of a shopping mall, you will have to take into account the cars, the bikes, the people passing by, the pets, etc. It all depends on the application requirements.
Wow, so then it have to have a lot of calculations to make? Or it doesn't matter how many, I guess, how many people or how many objects there are going to be, or? So
that's always a bit tricky to do a correlation between the number of labels and the model size at the end. But what I can tell you is that we use the FOMO machine learning architecture that has been developed by Edge Impulse, and it is very tiny, so it works perfectly on our microprocessors.
Okay. Yeah. Thank you, Hakim. It's a wonderful demonstration. Thank you.
Thanks for coming. My pleasure.
Hello, Hugh. How are you doing here today in the Embedded World?
It's brilliant to be here. It's such a cool event.
Could you please explain what your job title here in Microchip?
Yeah, so I'm Hugh Breslin. I'm a senior applications engineer and subject matter expert. So I specialize in FPGAs and SoCs, and also in PIC64, our 64-bit MPU products as well. So I actually started out, my background's in RISC-V and 32-bit compute, and then over the years I've gone into 64-bit compute and hardware, software, code design as well. So it's a really interesting job, actually. I have too many things to try and do.
but it's interesting for you. This is what matters, right?
Oh, it's my bread and butter. I absolutely love it. I wouldn't want to do anything else. So it makes it fun to go into work. Really.
Oh my God.
So it's brilliant.
All right. So you have prepared some demonstration for us today?
Yes, definitely. So today I'm showing you our Curiosity Kit, which is the first PIC64 kit. So this is our GX1000, our introduction to the 64-bit MPU market. So this kit's running Linux on our SoC, and also running a MIPI to HDMI bridge. So this isn't actually a video stream, this is picture-in-picture. So it's the HDMI input into the TV, and this is a laptop screen behind it. So you can see is the MIPI camera input going into PIC64 through our pipeline, and then coming out over HDMI. And then in the background, Linux is running on the kit as well. So we actually have 4 cores available for Linux. And you can see we have our pipeline running, then we're running a web server here in Python. That's just pretty simple. And then you can also play Space Invaders if you want to, which is quite fun. And the nice thing is the kit's not really breaking a sweat doing that. So we have a ton of compute power available with the 4 CPUs, so we can do all of this stuff at the same time, which is really fun.
So a lot of things on one board.
Device. What makes it even more interesting is that we have 4 CPUs. We can actually take one of them away and use it for a real-time operating system. So alongside Linux, we can run Zephyr. So Linux is really great for heavy lifting. Like if you wanted to run a web server or do some networking, that's brilliant. But if you had like an industrial machine, like a robot arm, you might have some real-time tasks. Like even if it's a big stop button on the wall to tell it to shut down, you want that to happen instantly if you push that stop button. So we can take away 1 CPU from Linux.
Wait, you want to do it immediately?
Yeah, if you put your hand in front of the robot and you want to go, oh no, hold on, turn it off, make it stop.
Yes.
You don't want Linux to go and say, I'll do that in a few seconds when I decide to. So with Zephyr, we can bring the real-time operating system in, it can control the safety critical tasks, and Linux can do the background heavy lifting for you. So that means then in one device, you can do multiple things. It's really, really flexible. It gives you a whole load of compute power and real-time safety at the same time.
So you put it all on one board, right?
All on one board, yeah, and it's even just all on one part. So we have some DDR on the kit, and then
And the IOs.
all the IOs and peripherals we need, but realistically you can run Linux and the real-time operating system on the PIC64 with some DDR on the side. And then you have the option of gigabit Ethernet if you want, the HDMI out, and then a whole load of peripherals. We have microbus expansion on this for I2C and SPI and whatever you'd like to do. So it's a really versatile part, it can do a ton.
What would be the 3D part? What?
It's a really versatile part.
Okay, very versatile part.
Yeah.
What would be your most the thing that you like the most from the ones that you have here? That's the most impressive for you?
The most impressive thing for me is how much it's actually doing, like with the pipeline running and then not using all of your CPU power, that you can go and do a whole lot more. So what I have here is really simple stuff. Like running Space Invaders is really fun, it's really cool, but the kit's not actually overwhelmed doing it. So if you think about it, you wanted to run a whole web server, you wanted to manage a robot arm and a ton of motors, you can do all of that. It's really hard to demo with such a small little kit, but it's a great platform to actually get started and figure everything out. So my favorite thing is the multitasking capability. So it really shows you so much.
Hugh, thank you very much for your time
No
and
problem,
demonstration.
it was really lovely to talk.
Thanks. Hello, Bill. Nice to meet you here in the Embedded World 2025.
Yes.
Could you please introduce yourself to our viewers?
Sure. Hi, my name is Bill Lee. I'm applications manager for the 32-bit microprocessor unit. My specialization is with the Microchip graphics suite tools.
Oh. So you prepared a demo for us about the solar farm management UI, so
Yes.
the user interface.
Yes.
Right.
So what I'm showcasing here is, first of all, our newly released microprocessor unit called a SAM A7B65 processor unit. It is a Cortex A7 processor running at 1 gigahertz, and it's showing the Microchip graphics suite development tool, which we use to develop this solar management UI, and so it's fully touch interactive, and this is running on C code but on embedded Linux, and so yeah, it's interactive, very versatile. It's in this case we're showing solar, but it's very easy to develop on, and we can use it for different type of applications. this particular display is driven by the SAM A7D65 using the LVDS display interface. The resolution of this display is 1280 by 800 resolution, which is an ideal size for this processor. It's a fairly low power and very easy to develop on. Runs on both embedded Linux as well as with our Harmony free RTOS framework system that we can use. And so yeah, as you can see, it's fully interactive with the ability to access different screens. So the screen transition is very smooth because of the capability of the processor, and so you're able to cycle through the screens fairly easily. Yeah. Mm-hmm.
So actually, this is really showcasing your. Let's say if you have your own house and you have solar panels and
Yes.
you have also some battery management system. So this one is going to be your, for example, your panel, and it can be controlled with your latest microprocessor.
Absolutely. That's
Right.
what we're trying to showcase here, is the ability to this form factor is ideal for like a home type system where you have a touch panel localized right at the battery, right at the solar, the converters, so that they can see the performance, and it's an ideal product for that.
Can I ask you, where else can we see this? Where else can we have some applications for that?
Oh yes, I would say so in this case I'm showing industrial, commercial, where we actually sometimes we also have like home appliances, such as think of an oven, right? A smart oven, or a fancy coffee machine.
A fridge.
Yeah, a fridge. Yes, these days fridge as large displays like that too. We've also have customers that are making commercial ovens. Like commercial ovens would use this type of product.
So this is already
Yeah.
in motion. So
Yes, we actually have customers that are interested exactly in this display size using the SAM A7D65 to product to drive
And
their
do you
product.
think there are going to be some modifications that are going to be done in the future for this?
Yeah.
Or do you have already the plans on what's going to be the next version? Or what we can do here better?
Yes, we certainly will be continuing to improve on this product. I cannot go into quite the details at this
Understandable.
moment, but yeah, like we're continuing to refine and improve this product to Microchip in general. We look to provide general purpose products that can hit on multiple industry segments, that can support different industry segments at the same time. So we certainly have customers that are in the automotive industry, as well as in commercial and in the industrial and in medical too. Like we even have this could be easily used for a patient monitor type application
Right.
too. Because the microprocessor is not just driving graphics, it can do graphics and support dual gigabit Ethernet at the same time, as well as with Wi-Fi or Bluetooth Low Energy, as well as different types of different I/Os. So it's very versatile. It can
Right.
be used in multiple different applications, even beyond what we're talking about here today.
Right.
Yes.
Oh, this is inside of the car.
Yep.
So it can show the speed and also the maps inside.
Yes.
of the speed
Yeah,
user.
and we're seeing a lot of interest in this with electric scooters, so what we're trying to show here is the ability to show maps, but the microprocessor that we have driving this display has the capability to drive a Wi-Fi module too, right?
Okay.
So imagine a very light form of Android Auto. Right, so it's the person might have a phone. The actual map data is on the phone. The navigation, the GPS is on the phone, but it's able to send over Wi-Fi the map data into this location. So imagine, and then this would be a round display on an electric scooter. Somebody has their phone in their pocket, probably programmed the map on there, and they're just driving. And then now they have navigation a very affordable form of navigation right on the display itself. Yeah.
Can we pinch it?
This particular one
okay.
right now doesn't
Okay.
pinch, but you can certainly pan
Okay.
through it for now. And but yeah, I now put this in auto demo mode so they can see the way it functions. We have a little demonstration here on the processor. It's a CPU usage and the frame rate shown. This is a real-time measurement of how efficient the software that's the library that's running on here so that it can free up the CPU for other functions, such as getting the Wi-Fi data into the display, as well as because this particular product has a CAN FD access, this microprocessor itself can function as a vehicle control unit for the e-scooter itself, right?
Right.
So so this is full form function. So managing batteries, managing the motor, as well as just driving this display, showing the battery levels, all that. You can imagine all that could be used with this gauge itself.
So it's actually like the navigation in the car.
Yes.
So you sometimes connect your phone to the Android maps or something like
Exactly,
that. Android
exactly.
apples. But this one is actually for scooters that we see the boom population, like the popularity is exploding in them, and then hopefully we will see, and maybe it will be even safer for the guys that are driving instead of
exactly. Instead of doing this, it's right on there, and they can quickly maybe glance down and look back up. It also has Bluetooth capability, so very likely maybe the rider has a headset or something. The Bluetooth can send instruction to the
turn left,
turn
right.
left, turn right. Yep.
All right.
Exactly. Yeah.
Wonderful.
Yeah.
Great. Thank you.
Yeah. Thank you.
Hello everyone, thank you for the invitation. My name is Carmelo, I'm with Microchip, and today I'm showcasing a 10BASE-T1S demo for industrial applications. So 10BASE-T1S has been developed originally for automotive applications, but we at Microchip have seen that also industrial customers could benefit from the technology. Nevertheless, industrial customers were a little bit skeptical because they were a little bit skeptical about the limitation in number of nodes and in the total distances of the network. So that we have created this demonstrator that showcases a 10BASE-T1S network connecting together 50 nodes over a total distance length of 98 meters.
98 meters.
98.
Wow.
So almost 100 meters. 50 nodes, 2 meters, node to node, so we have 98 meters. And what we can see here is a representation of the signal quality in this monitor, done with the so-called eye diagram. And so we can figure out the eye diagram like a human eye. When the eye is open, we can see very well, and so is for the signal quality. When the eye is open, we have a good signal quality. When the eye is closed instead, the signal quality is not so good. So, and on the other display, we can see the traffic that is going on the network, so that all the viewers can figure out that the network is working.
And it has also some buttons?
This is a very good question. Yes. So we can shut down one node here, and the network will continue to work. This is not the case, for example, for other networking technologies.
So it shows redundancy?
It shows the redundancy and the robustness of this solution.
All right. So you were mentioning that it is for the industrial applications.
Yes.
And what would be their benefits?
Very good question. So currently we have in industrial applications different specialized networks. For example, we need to connect sensors in the OT environment, so operational technology environment, we need to connect sensor together, but at a certain point we have the necessity to connect the industrial network to the cloud. And the connection to the cloud happens over an internet connection. So the connection between operational technology and information technology is done in the current solutions using a gateway. A gateway is a very complex device that is very expensive, and its development prolongs time to market. So using a node-based Ethernet technology, we would have all Ethernet connection from the sensor up to the cloud. This would mean monotechnological connectivity, so that single network type, no need of gateway, and cost reduction and faster time to market.
So no, we don't need to use those gateways right
We
now.
do not need to use these gateways anymore.
And also, previously we had much more wires to get the same amount of data traffic, right? So
This is a good question. So with other technologies, we could have a smaller bandwidth available. With 10BASE-T1S instead, we have 10 megabit per second. And the 10
using just two wires.
Using just two wires, yes. And 10BASE-T1S is not only suitable for connecting different sensor and inductors together, it could also be used in back panels applications, for example. And this is another advantage, so that you have a single networking technology suitable for different kind of applications, and enabling the connectivity on different physical layers.
Could you please elaborate on the first display that you were saying, that the eye right here, is it?
Yes, for sure. So we are now measuring the signal quality in the middle of the network. So if we move ahead, for example, we come here a little later than the middle. It takes some while,
Of course.
for the system to settle. We see the eye closed. So this means a little bit, not exactly. So this means the signal quality is not as good as earlier, but still good enough to stay within the 10BASE-T1S specification.
This is after 100 meters, right?
No, this is now, I think, after 75 meters.
All right.
So if we go at the end of the network, this is at the very end of the network. Okay, the eye closed a little bit more, but is still within the 10BASE-T1S specification. And as we can see, the network is still operating.
Right. So it can still get the data from whatever your sensors or...
And of course, we are now in a trade show environment with a lot of disturbances, and we are using very low-cost unshielded twisted cable. Also very low-cost connectors. So depending on the cable and the connectors that will be implemented in the final application, the signal quality could also significantly improve, so that 100 meters, even something more, is possible.
Right. So even with those low-cost products, you can achieve this 100 meters with acceptable...
Exactly, signal quality.
Yes.
Exactly.
That's wonderful. Thank you, sir.
Thank you so much for your time, for
you.
stepping by and visiting. And dziękuję bardzo for people speaking Polish, and thank you very much for your attention for everyone else.
Carmelo, thank you very much for your time.
You're very welcome.